Hello. So for today, we're going to answer the number 1 review problem for gas cycles in Thermodynamics 1 book by Hipolito Sta. So the question is this, the problem is this: an ideal Otto engine operating on the hot air standard with K equals 1.34 has a compression ratio of 5. At the beginning of compression, the volume is 6 cubic feet, the pressure is 13.75 psia, and the temperature is 100 degrees Fahrenheit. During the constant volume heating, 340 BTU are added per cycle. Find A. the clearance, B. the third temperature, as well as the third pressure, then the efficiency, and the mean effective pressure. So first, we have to draw our diagram so that we are guided for the formulas that we are going to make. We know that Otto cycle has two constant volume process, and then this is 0.1, 0.2, 0.3, 0.4. Then our heat is added at points 2 to 3 and then rejected at points 4 to 1. Okay. Now let us make the given. So what are the given values? First is, it said that K is 1.34. So if it is not given, then you have to assume that K is 1.3 since the air is hot air. The compression ratio, which is RK, it is the ratio of the beginning and end of the compression process, is 5. At the beginning of compression, we know the compression is from points 1 to 2. At the beginning, so that's 0.1, the volume is 6 cubic feet. And the pressure, P1, is 13.75 psia. Then the temperature is 100 degrees Fahrenheit. During the constant volume heating, 340 BTU are added. So this is the constant volume heating. So our QA is 340 British thermal unit. And then we have to find the C, T3, P3, the efficiency, and the mean effective pressure. And we have to assume that this is in PSI, since initially the given pressure is in PSI. Okay? Now let us answer. First, solving for A. So for our solution, we have to indicate what are we going to find. So for letter A, we have to solve for C, the clearance. So we know that clearance formula, we have a formula for clearance, and it is basically 1 over RK minus 1. And we can easily get the clearance as 1 over 5 minus 1. And that is 1/4. And we have to convert this in percentage. So we have our C is 25%. And this is one of our answer. Okay. So for B, solving for, let us also include C, solving for T3 and P3. First, we have to make some PVT relations, okay? Let us find the mass first using PV equals MRT. We have to find the mass. So that is, mass is PV over RT. So mass is, our P1 is 13.75 pounds per square inch. Our volume is 6 cubic feet rather. Our R, if it is in English unit, we are using 53.3. So this value varies because in our school we use 53.3, but in some other school they use 53.5, 53.33, something like that. So this is a varying value depending on the standard of your department, of your course instructors. So the unit here is pound feet per pound Rankine. And our T, we have to convert this into Rankine, so we can basically add 460, and this is 560 Rankine. So upon analyzing the units, we see that there is inconsistency in inches and feet. So we have to convert these inches into feet. And we can basically use 144 square inch over square feet. And we can proceed to answering this. So we can cancel inches. No. We can cancel two of the feet. We can cancel this pound. And we can cancel this. No. Sorry. So since there is pound and feet, we can cancel these two here. Then we can cancel this Rankine unit. And our M, our mass, is, let me just use my calculator, that is and we can use the fraction so that it is easily written. So that is 1485 over 3731 pounds. And we can store this at letter A. So I suggest here that you don't have you don't truncate your answers. It's better to write the entire value so that there won't be a discrepancy on the final answers. But it depends on your course instructor if that is the rule. Okay? But if you are not prohibited to round off your answer, then go ahead. Okay? So we have to solve for the temperatures. So first, at isentropic 1 to 2, we have T2 over T1 is equal to P2 over P1 raised to K minus 1 over K, and we also have V1 over V2 raised to K minus 1. So we can use anything we want, but I suggest we have to use this volume relation, since this V1 over V2 is just the compression ratio. So we can do is that T2 equals T1 RK raised to K minus 1. Now, so we have to get our answer as 560 times 5 raised to 0.34, that is 967.9163555, and let's store this at B. So now we have to solve for T3, but how can we do it? Note that we have a given value of QA, which is 340 BTU. So using QA, we can generate a formula to get our T3 as MCV times T3 minus T2. And we can just transpose this formula in order to get T3. Why? Since we have QA, we have mass, we have CV, and we have T2, we can get our T3. But first, we have to solve for our CV. We know that the formula of CV is R over K minus 1. And our R is 53.3. Again, this is a varying value. It depends on the preference of your course instructor. Then we can do is that 134 minus 1. And then, since our QA is in BTU, we have to convert this pound-feet into BTU. So we know that we have 1 BTU in every 778 pound-feet. And then we can cancel pound-feet, and we can only have BTU per pound Rankine. Our CV is So our CV is 0.20149705513, and we can store this at letter C. And now we can generate a formula for T3 by transposing this. So we have T3 is QA over MCV plus T2. Then we can just substitute the givens. So we have 340 BTU all over. Our M is at letter A, and that is in pound. Our CV is at letter C, which is at BTU per pound Rankine. And then our T2 is at letter B, which is in Rankine. And we can just cancel BTU and pound, so that we only have a Rankine value. So my T3 is 340 divided by A times C plus B, that is 5207.361473 Rankine. And this is one of our answers. So if you're going to see at the book, its answer is somewhat 5209 Rankine. So this is accepted since we did not round off any values all throughout the solution. Maybe the author get this value because he transposed the initial values. Okay, but this is also acceptable since this is the most accurate. What we get is the most accurate answer since we did not round off any values. Then to get the P3, we can do is that so what we can do is by doing another PVT relations. Okay, so solving for P3. So at isometric points 2 to 3, here this is isometric 2 to 3, we have isometric 2 to 3, we have T3 over T2 is equal to P3 over P2. So we have to find first our P2, but how can we find it? Okay, what we can do is that we have to go back here to get our P2, since here we have T2 na and P1 and T1, so we can get our P2. So I'm just going to copy this formula and then we have to proceed in the next page since we have no more space. And then I'm just going to write T3 over T2 is P3 over P2. So we have to solve for P2 first. We know that our T2 is at letter B, our T1 is 540 and our P1 is 13.75. So this is B over 540. Is it 540? No, it's 560. Sorry, it's 560. 560 equals P3. No, equals P2 over P1 raised to K minus 1 over K. This is 0.34 over 1.34, and we can just shift solve this to get the P2. Our P1, by the way, is 13.75. So it must be greater than P1. P2 must be greater than P1. So I get my answer is 118.8290169 psi. And we can store this at letter D. And then we can now proceed to here. So our T3 is at letter I did not store this, so let's store this at letter E. Okay, so T3 is at letter E, Rankine, all over. Our T2 is at letter B, also in Rankine, and our P3 we don't have P3, and then our P2 is at letter D, which is in pound per square inch. and this is our P3. And then we have what? So I get my answer as 639.2966095 psi. Again, there is a discrepancy in the book since the book round off initial values. Here we did not round off any values. So next is our efficiency. We know that we have a shortcut formula for efficiency, which is 1 minus 1 over rk raised to k minus 1 times 100%. So our answer is 1 minus 5 raised to 0.34 times 100%. And our efficiency is 42.143761%. And finally, for the last unknown, we have at letter E is we have to get the mean effective pressure. So the mean effective pressure, or P sub M, has a formula: work net over volume displaced, and work net is QA minus QR, and our volume displaced is V1 minus V2. Since we are given QA, also V1 and V2, it will be hard to get QR. So what we can do is that we can use this formula of efficiency in getting the work net. So how is that possible? We know that work net, the efficiency is also work net over QA, and we can just do is that work net is equal to QA times efficiency. So let us store this at letter F. Okay, since our work net is, I think, 340 BTU, our QA rather is 340, then our efficiency is at letter F, and then we would get a work net of what? Of 143.2887874 BTU. And let's store this at letter M. So PM is at letter M BTU, but we don't have V2. We have V1, but we don't have V2 yet. So again, we have a formula for RK using RK, that is V1 over V2, and then we get V2 as V1 over RK, and our V1 is, I think, 6, and our RK is 5, and we can just use this 6 over 5, and then finally we have 6 minus 6 over 5, and this is in feet cube. So to fix this unit, we have to do some conversion. We know that in 1 BTU, we have 778 pound-feet. So we can cancel this BTU, we can cancel this 1 pound, so we only have 2 exponent, and then we can do is we have to use 144 inch squared over feet squared to cancel the remaining feet. So finally we have PM is what? My calculated PM is 161.2828076 pounds per square inch, and this is our final answer. So we get our C, our T3, our P3, our efficiency, and our mean effective pressure. And if there are any questions, you can comment it in our comment box. Thank you for watching.